And in today's episode, among other things, you'll see robots mastering movements that used to belong only to us, human beings. While machines are starting to turn agility into real competition, entering arenas to duel with each other, we'll also talk about humanoids helping to build the next generation of other robots, and how physical artificial intelligence is starting to spread to electric vehicles. Meanwhile, robots are 3D printing concrete structures on the ocean floor. Autonomous systems are learning to neutralize swarms of drones, and scientists are making steady progress toward quantum communication networks, which could connect the future in a completely secure way. And as usual, when we put all this together, it becomes clear that we're not just evolving machines. We're teaching technology to act, react, and organize itself like a living ecosystem. Let's break it all down. Hello, impressed viewers. I'm Carlos Alves, and you're watching Amazing Reality. And there's a technology that's already working in more than 180 countries, and that many Brazilians are already using. It's Nomad, and I'll be straight with you, okay? It helps you stop losing money. Nomad converts your money to the currency of the country you're in, whether that's Brazil or abroad. You open your account in just 5 minutes, get the virtual card, and then the physical one. You can travel, shop online, or subscribe to foreign services without hidden fees or surprises. Pay attention to this part, okay? Nomad has launched its embedded subscriber identity module chip, which is international, and you only activate it when you arrive at your destination. It works on Android and iOS and gives you internet in over 30 countries. And if you're a Nomad PES level 1 to 4, you get 1 gigabyte for free. At level 5, the internet is unlimited for 15 days. And Nomad is giving $20 in cash back to new customers. But it's only for those who open an account right now using the code RI20 on their first currency exchange transaction. So don't waste time. There you go, my friend. Open your account through the link here in the description or in the pinned comment. Or there's even a QR code on your screen. Get your cash back now and stop spending way more than you need to. And of course, you also help Realidade Impressionante keep bringing you the cutting-edge technologies you always like to see here. You help me, I help you. Deal? In recent years, humanoid robots have been introduced to the public through dance, acrobatics, and martial arts. Not just as a spectacle, but as humanity, a demonstration of advanced body control. Now, during the Chinese New Year celebration, one demonstration drew even more attention. Engineers placed a sword in the hands of a humanoid robot. The robot, nicknamed by the Chinese media as Ling Hu Xiong, in reference to a famous fictional swordsman from Chinese literature. It performs sequences of strikes, thrusts, and acrobatic movements inspired by traditional martial arts. The goal is not to create a combat machine, at least that's the official information, but to demonstrate how far balance control, coordination, and motor precision have come. In modern robotics, the platform used is the RoboChair L7, a humanoid introduced in July 2025 with support from Tsinghua University. The model has 55 degrees of freedom, allowing for independent and complex movements in various parts of the body. The arms alone have 7 degrees of freedom, while the hands have multiple articulation points for physical manipulation. This level of mobility allows the robot to perform quick turns, jumps, and sudden changes in posture without losing balance. Something that, until a few years ago, was one of the biggest challenges in humanoid robotics. The use of swords and choreographed movements serves as a showcase for deeper capabilities. Each gesture requires an interaction between visual perception, movement planning, and real-time dynamic control. In other words, it's not about a weapon, it's about the body, learning to move more and more like our own species. RoboChair had already demonstrated many examples of a sword with a sword, a robot. The recent video reinforces a very clear trend. Robotics is leaving the controlled environments of laboratories and moving toward demonstrations of increasingly natural physical abilities. In the end, the scene of a robot wielding a sword may seem like just marketing, but it symbolizes something bigger. We are seeing machines not just executing commands, but mastering movements that require timing, balance, and coordination that are almost human. A significant step in bringing technology closer to real physical behavior. And while the world is impressed by a robot wielding a sword, engineers are already turning this kind of skill into an entire sport. Engine AI has just turned what seemed like mere viral marketing into something much more serious. A real arena where humanoid robots will fight, fall, get back up, beat each other up, and evolve in front of the whole world. During an event in Shenzhen, the company officially introduced the URKL League, an international league of biped robot combat, which promises to accelerate the development of robotics, just like Formula One boosted the automotive industry. And, to make the ambition clear, the championship will have a gold belt valued at about $1.4 million. The proposal goes beyond the spectacle. The league will bring together 16 teams from universities, companies, and research centers, divided into groups and elimination rounds until a champion is crowned. But unlike competitions like BattleBots A, the focus won't be on destroying opponents with aggressive modifications. The main goal is in the software, in balance, and in movement intelligence. The rules make this clear. Each match will be the best of 3 rounds, with 5 minutes of actual combat, where hits will be exchanged in every round. If the robot falls, it has 10 seconds to get up on its own. Failing means relying on limited manual resets. And if the limit is exceeded, it's a technical knockout. Changing batteries during the round, that's forbidden. In other words, it's not just a fight, it's an extreme test of body control, energy efficiency, and physical endurance. The main star of the event is the Humanoid T800, equipped with a maximum torque of 450 Nm as well as modular batteries and active cooling systems. Every fall, impact, and recovery inside the ring works as a real experiment to develop the robots, which will eventually operate in factories, stores, and unpredictable human environments. It's a fact that there are already similar leagues in the United States, but they rely on remote control and virtual reality. Just like in that movie Real Steel, by the way. I need to bring a future video with all this info for you. So, if you haven't subscribed yet, take a moment to check if your notification bell is on. Getting back to RKL now, the Chinese league is different. It seems to aim for autonomy and local decision-making. The robot needs to react on its own, maintain stability, and manage energy like a complete mechanical athlete. The timing of the competition is no coincidence, with the T800 already available for pre-order at around $25,000 and deliveries expected later this year. The league also serves as a global showcase for the hardware's robustness. At its core, this is fascinating. The ring is now a lab, and competition has become a research tool, and each fall can represent another step toward robots capable of surviving and working, of course, in real environments. Watching machines fight and balance themselves is impressive, isn't it? But there's something even more symbolic that's already happening behind the scenes in robotics. The moment when robots stop being just competitors and start working on creating the next generation of other robots like themselves. Universal Robotics is clearly moving to a new phase. After attracting attention with extreme demonstrations, such as tests at temperatures of 47 degrees, the company is now shifting its focus to something much more strategic, turning its humanoid robots into real workers within the platform. In a recent video, the humanoid iRobot appears assembling parts inside the company's factory. It's no longer just choreography for marketing or an isolated endurance test. It's a clear attempt to prove that the robot can generate real economic value. Behind this change is a new embedded AI model called Unifo LMX-1. This is an evolution of the system that Unitree was already using for data collection and training. The idea is powerful, using robots to build other robots, thus creating a closed loop where each task performed becomes a new learning experience. This process is powered by a concept of human in the loop. Human operators still guide some of the movements through teleoperation, allowing artificial intelligence to learn concrete and efficient gestures directly in the real world, not just in simulations. Until now, G1 was known as a technological actor, appearing at events, dancing, fighting, or participating in carefully controlled demonstrations. Entering a factory environment represents both a symbolic and practical change, leaving the stage and entering production. This step is directly linked to the goal advocated by Chief Executive Officer Wang Xingxing, known internally as the I-80 objective. This is the moment when a robot will be able to perform 80% of tasks in 80% of unknown environments. Although Unitree's own factory is still a controlled environment, it offers the kind of repetition and complexity needed to bridge the gap between demonstration and commercial reality. There's also an obvious economic factor, with more than 5,500 units of the G1 shipped in 2025 alone, and an initial public offering planned for mid-2026. The company needs to convince its investors that its robots are not just impressive, but profitable. That's why putting humanoid robots to work internally is also a way to prove return on investment before going public. The big question that remains is the same one that hangs over the entire humanoid industry. Can these skills learned inside the factories be generalized to real customer environments where they're needed? If the answer is yes, Unitree won't just be creating robot factories, it will be teaching machines to evolve right where they're born. And for that, they use what's called physical intelligence, and that's not just limited to humanoid robots. It's already starting to spread to machines that are part of our daily lives, including vehicles that, for now, are not just electric cars. They're ceasing to be just battery-powered machines and are becoming intelligent systems, capable of interpreting their own behavior in real time. And the new breakthrough, which I even mentioned a little while ago here, shows that the next stage of autonomous driving might not just depend on more sophisticated sensors, but rather on something deeper, understanding the physics of the vehicle while it's in motion. Researchers led by Professor Kang-Yoon Nam have developed a system that combines traditional physical models with artificial intelligence to estimate the vehicle's critical states in real time, especially those that cannot be measured directly by the sensors. One of the main challenges is the so-called lateral slip angle. It is what reveals when the car starts to skid during turns or on low-traction surfaces. Detecting this moment early is essential because any delay in response can compromise braking, stability, and control. This is even more critical when you're driving the car alone. The problem is that the behavior of the tires changes all the time. Temperature, speed, wear, and type of asphalt completely change the dynamics of the vehicle, making classic models insufficient for real situations. The solution created by the team was a hybrid architecture. Instead of abandoning physics, they reinforced traditional models with data-based learning, and the result is a system capable of adapting calculations in real time, understanding changes in tire behavior and also in the environment much faster than in... My friends, when machines are able to understand their own movement in real time, they gain something essential: the ability to operate in environments where humans can hardly function. And that's exactly what's allowing automation to reach extreme places, even at the bottom of the ocean. 3D printing has already left the laboratories some time ago, but now it's starting to cross a frontier that, until recently, seemed impossible: the bottom of the sea. Researchers at Cornell University are developing a system that can print concrete structures directly underwater, using an industrial robot that weighs about 2,700 kilograms. The goal is simple in concept, but extremely complex in execution: to build and repair ocean infrastructure without having to bring ready-made structures from the surface. The project was born after a challenge launched by Defense Advanced Research Projects Agency, which called for solutions capable of printing concrete at depth, using mostly local sediments. The proposal aims to reduce logistical costs and the environmental impact caused by the traditional transport and installation of underwater structures. Unlike conventional methods, which require parts to be built on land and then positioned in the ocean, the team works with the opposite logic, bringing the construction to the site, causing as little disturbance as possible to the marine ecosystem. But printing concrete underwater is not just a matter of taking a robot to the bottom of the sea. The biggest challenge is the material itself. Water tends to wash away the cement before it solidifies, completely compromising the structure. To solve this, the researchers developed a specific mixture that balances strength, stability, and pumpability, preventing the concrete from breaking apart during printing. Another critical point is viability. Fine sediments can turn the water into an almost opaque environment in a matter of seconds. That's why the team integrated advanced sensors and autonomous systems, which are capable of guiding the robotic arm even without direct visual contact. It's a fact that building infrastructure in hostile environments is already a huge leap, but the same combination of robotics and autonomy is also changing. Another area where mistakes and reaction time make all the difference. Up in the skies, machines are now learning not only to build, but also to defend. The United States Army has just demonstrated the Coyote Block 3 developed by Raytheon, showing that it is indeed possible to neutralize entire swarms using a single electromagnetic weapon. All this without explosions, without direct impacts, and most importantly, without wasting high-cost interceptors. Drone swarms represent a difficult threat because they can saturate traditional defense systems. Each interceptor launched costs hundreds of thousands of dollars, while the attacking drones often cost only a fraction of that. The result is an economically unbalanced war. The Coyote Block 3 was developed precisely to reverse this equation, unlike previous versions, which worked with disposable Coyote missiles, a limit, other shared brands. Seed. The Ultimarata moon has pregnant women, provinces, obstacles, night wish, much easier manifestation, first radcaffers, and the form. An invisible attack with no direct impact, no shrapnel, just a pulse that turns cold. The Protecto Fish Area Dioxide Chavinia, operated by a network, drastically reduces operational costs and thus allows multiple operations with less equipment. During the tests, about 10 drones attacked simultaneously from different directions. The system used radar and onboard intelligence to identify threats, automatically distribute targets, and decide the best way to respond, all with minimal human intervention. In other words, the machines are already starting to make decisions on their own. When autonomous systems begin to operate in a network, a new limitation appears: how to ensure fast, secure, and impossible to intercept communication. Because the next leap in technology doesn't just depend on smarter robots, but on how these machines can connect with each other. And with that in mind, China has just made a leap in quantum communication. Scientists at Peking University decided to tackle a challenge that is just as important as processing power. How can these machines communicate with each other in a secure and efficient way? In a recent experiment, the team demonstrated an architecture that is capable of achieving secure quantum communication over distances equivalent to 3,700 kilometers. An advance that could accelerate the birth of future global quantum networks. The big problem is that current quantum communication, which is based on so-called quantum key distribution, although extremely secure, still has some very serious limitations. It requires expensive equipment, depends on trusted intermediary nodes, and doesn't scale well when many users need to connect at the same time. In other words, it works in the lab, but it's still far from being the internet of the future. To overcome this, Chinese researchers have come up with an elegant solution. On the server side, they used an ultra-stable optical comb, a system that generates laser lines synchronized with extreme precision, acting as a central clock for the entire network. On the client side, 20 independent quantum transmitter chips come into play, capable of encoding information into light pulses, which are sent through standard optical fiber. Each pair of chips managed to communicate for about, adding up all the channels, the total capacity reached the equivalent of 3,700 kilometers of secure communication. The results caught the world's attention. A success rate close to 97.5% high stability, and, most importantly, production based on industrial wafers, which paves the way for large-scale manufacturing. Despite all of this, perhaps the most relevant point is another one. All of this works using existing fiber optic cables, meaning there's no need for an entirely new infrastructure. The impact of this goes beyond the laboratories. Practical quantum networks could mean virtually unbreakable communications between cities, financial systems, and critical infrastructures. It's a step toward a world where digital security no longer depends only on algorithms, but on physics itself, on the universe, on movement. I need a robot with a sword, all the way to the quantum network capable of connecting machines. On a global scale, everything points in the same direction. Technology is no longer just a tool. It's starting to function as a living system that learns, builds, and adapts autonomously, almost on its own. And maybe the most important question now is this: when machines really start to evolve and do it together, what will be humanity's next step in this new scenario? So if you enjoyed this episode, leave your opinion down below. Give it a like and make sure you're subscribed. Thanks for staying with me. See you next time. Just click one of the 2 suggestions on your screen. Thank you so much. All right, thanks. Bye-bye.